What's up, guys? Welcome back. Today we are covering transactions and the transactional annotation. So the easiest way to explain this is with the bank account analogy. So you have person A and person B. They both start with $50, and person A wants to send money to person B. So you have to do two things. You have to deduct $10 in person A's account, and you have to add $10 in person B's account. So at the end of the transaction, you will have $40 and $60 respectively. This is all well and good, but what happens if something screws up? Let's say person A tries to send person B more money than they have in their account. Well, on one side of the transaction, it would fail. But on the other side of the transaction, person B still got $70. So we have to be extremely careful when we code things like this, because with a transaction, it's either all or nothing. Meaning if any one part of it fails, you need to roll back the entire transaction like it never happened. So a quick note, the transactional annotation will do many things. It will automatically roll back if a runtime exception is thrown. However, the exception thrown must be a runtime exception or extend the runtime exception. So just a simple exception will not count. And it will automatically commit to the database. So you don't need to call repository.save. It'll automatically do that at the end of the method. So in today's video, we're going to create a new Spring Boot project. We're just going to start from scratch this time. We're going to set up the bank account example, including the repositories as well as the SQL queries. We're going to see that it's not working without the annotation, meaning it doesn't save and it doesn't roll back. But once we add the transactional annotation, we will observe an auto commit and observe a rollback in the event of an exception. Okay, let's get started. Okay guys, first things first, we're going to create a new project. We did this at the beginning of this series, but I'll just show you how to do it again. So go to the Spring Initializer website. This is start.spring.io. We choose our language of Java. We're going to use Maven. Choose the latest one that's not a snapshot. And here are our dependencies. So Spring Web, Lombok, JDBC, and Spring Data JPA, and you can rename it to whatever you want. Once you download it, you're going to get a zip file. Go ahead and unzip the file, and then import this folder into IntelliJ. Okay, so we still need to set up some things. So go over to application.properties, and you need to put in your data source. We're keeping it the exact same as we did with our original project, but go ahead and put in your URL, username, password, and we will need the driver-class-name, which is our JDBC driver. And we will need to add one more dependency to connect to MySQL, so go over to your POM file and add in this dependency. And then do a Maven refresh, and then run your project to make sure you get no errors. Okay, let's start by setting up our MySQL workbench. Go ahead and run this query. So we're going to create a table of bank. It's going to have a name with a varchar that is our primary key, and a balance, which is a decimal that is not null. And this 2 represents 2 decimal places. Then we're going to insert 2 values into our table. So Peach is going to have $100, and Barry will also have $100. When you're done, do a select star from bank to make sure that it's set up properly. Okay, let's set up our background stuff. You should know how to do this by now. So I'm going to create a new folder. I'm going to call it transaction. In the folder, I'm going to have an entity class. I'm going to name it bank account. So it's going to have entity, data, table annotation with the name of our table, which is bank, and then ID column with the name of name, private string name, and then a column of name balance, which is a private double balance. Next up, we need our repository interface. So new Java class, create an interface. I'm going to call it bank account repository. We annotate it with @repository, and it extends the JPA repository. And it is type bank account and type string. Then we make a new Java class. This will be our controller. So bank controller. We annotate it with @rest_controller, and we're going to add a post mapping with /transfer. Public response entity transfer. It will have a request body of a transfer DTO, which we will now define. So new Java class, transfer DTO. We're going to annotate it with @data, so it handles our getters and setters. and it will have 3 fields: private string from user, private string to user, private double amount. Okay, let's create a new class. New Java class, transfer command handler. We will annotate it with @service. And after testing, we will later come back and annotate it with @transactional, but not yet. We need to inject our bank account repository, and we will do that using constructor injection. We will then have one public method, public response entity transfer, and we pass in a transfer DTO. Then we will have an optional of bank account. From account is equal to bank account repository.findById. We say transfer.getFromUser. We're then going to do the exact same thing, but we're going to get the toUser. We'll do a quick check. We'll check to see if either account is empty, then we'll throw a new runtime exception. Then we will actually grab the bank accounts from the optionals. Next up, we need to add and deduct the amounts from each respective account. So let's create a new method, private void deduct. We pass in a bank account and an amount. And if the bank account.getBalance is less than amount, then we'll throw a new runtime exception. So just to reiterate, this must be a runtime exception for the transaction to be able to auto rollback. If it's just a regular exception, it will not work. Then we will go ahead and decrement the amount. So bank account.setBalance, bank account.getBalance minus amount. Let's add another method for adding to a bank account. So private void add, and we pass in a bank account and an amount. And then we will set the balance to the current balance plus the amount. We're then going to call the methods. So add and deduct, where we pass in the respective bank account and the amounts. And notice the order in which we did this. We did add first. We are relying on the rollback to happen even if deduct is later thrown with an error. We will then return response entity.OK. Before we move on, let's go ahead and just put a system print line statement so we can really see what's happening. So in between add and deduct, we have added to one account, but we haven't checked the other account to see how much money it has. So I'm going to add in a print line statement after adding, before deducting. And then I'm going to call bank account repository.findById to.getName. So this is important. It's not just the bank account that's in memory. We're actually looking at the repository. What is it in MySQL at this exact instant? And one other thing to note is we never called the repository.save method. Again, once we add in the transactional annotation, this will automatically happen. Okay, let's link up our controller. So we're going to inject our transfer command handler and then use constructor injection. And then we will return transfer command handler.transfer and we pass in the DTO and run your project. Okay, let's test it out. Since we do not have the transactional annotation, we are expecting this to not work correctly. So go over to MySQL and do a select star from bank. And we have Barry and Peach both with $100. I have created an endpoint, so it is a post with /transfer. And in the body, we pass in the DTO, so from user Barry to user Peach. And let's put in an amount that Barry does not have, so amount of 1,000. And just as we expected, we get an internal service error. And if we put in amount of 10, then we get a success message, but because we never called repository.save, nothing happened. So coming back to our command handler, let's add in the transactional annotation and rerun our project. Okay, let's do an amount of 1,000. We know that this should throw an error, and we get an internal server error. Great. So if we do a select star, we can see that both balances are still correct at $100. But let's go into the console and see what happened. So after adding, but before deducting, we can see that when we went to the repository, the balance was $1,100. So for a brief instant, Peach had $1,100 in the account. But once we went to the deduct method and found that the other account didn't have enough money, it rolled it back. So the transactional annotation did automatic rollbacks here. Next up, let's do an amount that will go through, so amount of 10, and we get a success message. And when we check MySQL, it did end up going through. Even though we never called repository.save, the transactional annotation handled it for us. Okay, that's all I have for you for this video. Thank you for joining us.